Hello, my name is Whitney Krushel, and I'm a wildlife biologist with the U.S. Fish and Wildlife Service. Prior to this position, I was a graduate student at Louisiana State University, where I was primarily studying wetlands. And today I'll be talking to you about the refuge where I'm currently stationed and some of the major issues facing the wetlands up there. And as you can tell from the title of my talk, I'll primarily be discussing issues revolving sediment. So I'm stationed at Agassiz National Wildlife Refuge, which is located up in northwest Minnesota. This area was once covered by the ancient glacial lake Agassiz, which covered all of northwest Minnesota as well as parts of Canada about 10,000 years ago. And when that lake receded, it left behind a very flat landscape with little change in elevation. And so with time, that area became colonized by grasslands, primarily with aspen stands and some oak savanna occupying the slightly higher ridges. And then in the low-lying areas, there was an abundance of wetlands. Where the refuge is located is known as an ecological transition zone, where we have tallgrass prairie to the west and boreal forest to the east. And we're also located on the very edge of the prairie pothole region. And because of this diversity of ecosystems, we also get a wide range of different wildlife that utilize that habitat. It's very diverse. The area surrounding the refuge is predominantly agriculture. The map on the lower right is a map showing the outline of the watershed where the refuge is located, and the refuge is indicated there by the black polygon. All the different lines, the blue lines on the map, are all drainage ditches. And so you can just see how dense the drainage system is in that watershed. And this is a product of a project that went on in the early 1900s where the watershed was heavily ditched and drained, as you can see by that newspaper headline from 1915 discussing the extent of that project. And then these are some old photos just showing the effort of that ditching project. And so even the area where the refuge is located today, farming was attempted there, and that area was also ditched and drained. But because it turned out to be unproductive, the state ended up taking that land back and then ultimately establishing it as a federal wildlife refuge. And so the Agassiz National Wildlife Refuge was originally established in 1937. But when it was restored as a refuge, it was restored as a series of wetland impoundments because the land had already been so hydrologically modified. This is what the refuge looks like today. The purple boundary line shows the border of the refuge, and then all the different red lines are the different habitat management units. And most of these units are wetlands. We're about 60% wetlands in terms of area. And then we have 22 impoundments that we actively manage. We have quite a variety of wildlife, as I already mentioned. We get up to 300 different species of birds. The duck use annually is up to 100,000 individuals with up to 7,500 pairs of nesting ducks. We're also known for the largest nesting colony of Franklin's gulls in North America, and that photo in the lower left is one of those gulls. And then we're also home to half the remaining moose in northwest Minnesota. This is a map showing, again, the watershed in green, and everything drains from east to west, north to south. And the main thing I wanted to just point out in this slide was that a majority of the water flowing through the watershed ends up flowing through the National Wildlife Refuge. And the refuge boundary is indicated in red, and Agassiz Pool there, that's our largest wetland impoundment. And these three other polygons in blue, pink, and yellow are subwatersheds that flow through the refuge. And as I said, they're largely draining agricultural fields. And the two main channels that flow through the watershed are the Thief River and the Mud River, as you can see on the map. And they both also flow through the refuge and carry quite a bit of sediment with them. So both the Thief and Mud Rivers enter and exit the refuge in channelized form. And again, the primary land use in that watershed is agriculture. And there are about 1,200 miles of ditches upstream of the refuge that are being drained, mostly draining agricultural land. And as a result of this, sedimentation and nutrient loading are major concerns for both the watershed as well as the refuge. So because of this sediment problem, It's been known to be somewhat of an issue for a while. So there have been some research studies that have investigated this. And back in 2008, a sediment fingerprinting study was conducted in which sediment cores were taken out of Agassiz Pool, which is our largest wetland impoundment at about 10,000 acres. And using radioisotopes, they were able to evaluate the volume of sediment that had been deposited in the pool, as well as the loss of water depth and the source of the sediment. And so this is a map on the left showing Agassiz Pool. And what they found from that study was that over 2 million metric tons of sediment had been deposited in refuge wetlands between 1940 and 2008, which amounted to about 29,000 tons per year. And using those radioisotopes, they were able to determine that crop field erosion was the main source of the sediment. There was also a question on whether bank erosion was a source of that sediment as well, but it turned out that that wasn't the primary source. The image on the right is an aerial image showing a sediment plume in Agassiz Pool. There's a main ditch or channel that flows through Agassiz Pool, and that's the Mud River, also known as Ditch 11. And the channel facilitates flow through the refuge, but there are breaks in the levee, which allows water and sediment to flow between the pool and the channel, and it's unregulated. And so that's what you're seeing in the image on the right is water making its way from the channel into the pool and bringing with it quite a bit of sediment. And when that process happens, you get that land building, and that's contributed to the expansion of emergent vegetation out into many of the wetlands. And unfortunately, in our case, that emergent vegetation is almost universally invasive cattail. And these two images also illustrate that issue. On the left, you see a photo of Agassiz Pool from 1948, and then on the right, you're seeing Agassiz Pool again in 2006, and you can see that encroachment of vegetation moving out into the pool and the loss of open water. So following that sediment fingerprinting study, there was a structured decision-making workshop in which refuge staff, as well as local and regional stakeholders and technical and scientific experts all came together to try to figure out, okay, what do we do about this? We know that this is a major issue. What are the potential solutions? And so they worked together to assess multiple alternatives and ended up selecting one that was relatively inexpensive and relied on existing infrastructure. And what that strategy was to start conducting annual fall drawdowns. And what that meant was dewatering Agassiz Pool at the end of the growing season within a short time frame, about 2 to 3 weeks. And that rapid drawdown would then mobilize those legacy sediments and help pass them downstream. And this is a photo showing our radial gates. This is our largest water control structure, and this is the outlet of Agassiz Pool. So this is what we will open every time we want to release water from Agassiz Pool. And these gates open from the bottom, which helps mobilize and facilitate that movement of sediment down the channel. The benefits of these annual fall drawdowns are that it's a relatively passive management strategy with limited downstream effects because we conduct it within a short time frame. And we always do this in coordination with watershed partners, including the Red Lake Watershed District and the city of Thief River Falls, which is located at the bottom of the watershed. So they know whenever we're discharging and conducting this event. It's an effective strategy. We know that we're mobilizing sediment. It's obvious, you can see it happening. And then it's also affordable. It's not an incredibly expensive management strategy. The major drawbacks to this strategy are that it doesn't solve the issue of incoming sediment. We still get tons of sediment entering refuge wetlands every year. And we also don't know how effective this strategy is. We know that it is moving sediment downstream, but how much sediment and whether or not we're having a significant reduction in the amount of sediment in Agassiz Pool is still unknown. It has not yet been quantified. And then finally, it's a bit of a controversial strategy. Even though we had that decision-making workshop with many partners, there are still some folks out there who are critical of the management strategy. And we want to maintain a positive working relationship with all of our partners. So it would be ideal if we didn't have a strategy that was controversial in any way. So this leads us to where we sit today. We're still trying to investigate this issue and learn more about it, and this will help us better figure out the best options moving forward and how to deal with this issue. This is again showing a map of the refuge and the two main channels that flow through it, as well as the many other ditches that flow unregulated into the refuge and carry sediment with them. So one of the projects that we're working on to learn more about this issue is collecting bathymetry data on Agassiz Pool. This past fall, when the pool was in drawdown, I started collecting elevation data. And with this data, we'll have a better understanding of the elevation of the bed of the pool and then whether or not that's changing annually and over the long term if we continue to collect transects within this pool on an annual basis to look at that change. We're also investigating sediment dynamics in the channels, and this includes collecting water quality samples at the inlets and outlets of the refuge to look at total suspended sediment in the water column, as well as other nutrients and parameters in those major channels. We're also exploring a river restoration project on the east side of the refuge, and what this entails is essentially restoring an old channel that's not currently functioning as a river channel at this point. And by doing so, that would restore the floodplain function around that channel, and that would help capture sediment moving with that water before it enters Agassiz Pool and deposits in the wetlands. And then lastly, the most ideal strategy would be to restore the levees along the channels that flow through Agassiz Pool. As I mentioned earlier, these channels do flow through the pools, but there are breaks in the levees, which allows water to flow unregulated into the wetlands. So if there's a way to fully restore these levees, perhaps install some water control structures in them to be able to regulate that flow, that would be the best option. And then ideally, water could pass completely through the refuge without affecting our wetlands. So that would be the best option, but of course it's a very expensive one. So in summary, the Agassiz National Wildlife Refuge is located in an agriculturally dominated landscape, and most of the water in the watershed ends up passing through that refuge, draining much of that agricultural land. Because of this, Agassiz Pool and other refuge wetlands are filling in with sediment. This is primarily from crop field erosion. There was a decision-making workshop held with partners, which led to a strategy that appears to be working, but it has yet to be fully quantified and evaluated in terms of how significant its effects are. And so we're continuing to explore potential solutions because sediment infilling continues to be an issue. And this is a photo I took just a few days ago when I was collecting water quality samples from major inlets and outlets around the refuge. And I just thought it was a great example to visually see how different the water looks coming into the refuge versus leaving the refuge. And that's all I have. And thank you for your time listening to my presentation. And I hope you learned something and I hope you enjoyed it. Thank you.